Good afternoon. I'm Colin Murdoch, Chief Business Officer at DeepMind. And I'm responsible for taking DeepMind's incredible AI research out of the lab and putting it to good use in the world. Over the next 15 minutes or so, I would like to tell you about what I think are some incredible AI breakthroughs that are having enormous impact in really important areas like health and sustainability. And I'd also like to try and answer what I think is a really important question, which is how do we make sure we're building a safe, ethical, and inclusive AI-enabled future? If you don't know DeepMind, our mission is to solve intelligence, to advance science, and benefit humanity. And our early research was focused on games, like the classic Atari computer games. Maybe you played as a child. Maybe you still play, I don't know. And the board games, like chess and Go, because these were the perfect proving ground to develop and test our algorithms. And it spurred absolutely huge breakthroughs in fundamental AI research. And that's now given us the tools we need to apply to these huge challenges in the real world. And I'd like to talk you through just a few examples of what that looks like. First example is what's called protein folding. So proteins are the building blocks of life. Just about every important process in your body and in nature relies on the proper functioning of a protein. The challenge is determining the structure of a protein was really hard. It would take years of painstaking work and millions of dollars of equipment to determine the structure of just one protein. In fact, as a rule of thumb, you would spend an entire PhD trying to determine the structure of a protein, if it was possible at all, in fact. But if you can do it, then you can really help advance solutions to really important problems, like antibiotic resistance, finding treatments for disease, or even potentially cleaning the plastics from our oceans. Which is why, actually, scientists for over 50 years have been working on what's called the protein folding problem. So proteins are actually made of a string of amino acids, a 1D sequence of amino acids that's coded for in your DNA and my DNA. In our bodies, these 1D structures spontaneously fold into three-dimensional protein structures, often in a matter of seconds. Which means, in theory, it's possible to determine the 3D structure from the sequence of amino acids. In practice, though, it's actually really hard. There are over 10 to the 300. 10 to the 300. That's way more atoms than there are in the universe, ways that amino acid structure can fold. Now, this is exactly the sort of problem we like to solve at DeepMind. In fact, we call it a root node problem, because if you solve the root node problem, it unleashes the potential for huge downstream impact. And in this instance, helps to usher in what we call a new era of digital biology. So I'm extremely proud to share that a team at DeepMind in November 2020 built a model called AlphaFold, which was recognized as a solution to the protein folding problem. They worked tirelessly, a group of structural biologists, AI researchers, engineers, and others, really inspired by all the fundamental research we've done at DeepMind, including, for example, work on natural language processing. But rather than, say, translating from French to English, in this case, we're translating from an amino acid sequence to a 3D structure, so that we can now determine the structure of a protein in minutes. We've gone from years to minutes. It's really quite mind-blowing. And that means we've been able to determine the structure of 200 million proteins. I think that's just about every protein known to science. And we've put that in a database, and we've made it available to everyone. It's been cited over 2,000 times now, that database, and has been accessed by over 500,000 people. It's incredible. It's also having impact in the world. There's a group in Colorado that are using AlphaFold predictions now to speed up their research into antibiotic resistance. That is a hugely important problem. There's another group at the Center for Enzyme Innovation who are using AlphaFold predictions to accelerate their research into plastic-eating enzymes that hopefully one day can clean up all the junk plastic that's in our landfills and in our oceans. And we've also, and this is really exciting for me, we've launched a new business called Isomorphic Labs out of DeepMind. And Isomorphic Labs' mission is to reimagine drug discovery using AI. It takes about 10 years from the start of a program to approval for a drug to come to market, and billions of dollars. Actually, the really sad thing is, most, in fact, the vast majority of drugs, when they get to the clinic, they fail. Which is why Isomorphic Labs, for me, is really, really important and really exciting. I'm looking forward to see how Isomorphic Labs develops and works with pharma partners and others to really transform that industry. So AlphaFold has been a real game changer, and for me, an incredible example of how AI is making a huge difference on these really big challenges, and at what DeepMind we call root node challenges. Let me talk to you about another challenge we've been working on now. So for years, scientists have been trying to find greener and cleaner sources of energy. And of course, nuclear fusion, the power that powers the stars in our universe, is one really important example. Nuclear fusion works by smashing hydrogen atoms together at really high temperatures. They fuse together and release huge amounts of energy, which can then be used, for example, to heat water, to turn into steam, to turn a turbine, to generate electricity. And back here on Earth, scientists try to recreate these mini-stars in nuclear fusion reactors. And one important example is a structure called a tokamak. You can think of this as about a 6-meter wide donut. And inside that donut, scientists try to create these plasmas of hydrogen at temperatures hotter than the core of the sun. As you can imagine, these plasmas are really erratic and chaotic. And so to control them around the tokamaks, they're really big, powerful magnets that interact with the plasma thousands of times per second. So this sort of control problem, controlling plasmas, again, is exactly the sort of problem we like to tackle at DeepMind. So much like the games I mentioned earlier, Atari, Chess and Go, apart from this time, the game is controlling plasma in a nuclear fusion reactor. And the team built a model inspired by the techniques that we developed for games, using a technique called deep reinforcement learning and simulators. And they created a controller that was able to control the plasma, interacting with it over 10,000 times per second. We actually work with an amazing organization called EPFL, who have a nuclear fusion research lab in Switzerland, and they extremely kindly let us apply our controller to their live nuclear fusion system. And as you can imagine, we were very careful. The great news is we were able to control the plasma so it was stable. And even better, we were able to sculpt and shape the plasma to make the reaction more efficient and more prolonged. For me, another really amazing example of how AI can make an incredible difference to these important problems. And I really hope, personally, it helps to advance nuclear fusion as a source of energy. So as well as solving nuclear fusion and protein folding as part of my day job, I'm very focused on how we can use AI to tackle really big and important business problems. And for that reason, I've developed, and DeepMind has developed, what I think is one of the world's largest and most powerful libraries of AI solutions. And our parent company, Alphabet, which includes Google, I think about as a marketplace of hundreds, if not thousands, of AI-ready problems just waiting for our solutions. And so we work together to apply those AI solutions to really big and important business problems, creating useful products for users all the way around the world for the moments that really matter. And I hope enriching the lives of billions of people. For example, Android cell phones. I think there are at least 1 billion users that use Android. And one of the most requested features you get for an Android phone is, can you improve my battery life? Maybe compared to nuclear fusion and protein folding, that doesn't sound that important. But as well as the day-to-day convenience, actually having power when you really need it, perhaps in an emergency, it could actually be a lifesaver. So the team at DeepMind developed a model that is able to predict which apps you're going to use next and which you might not. And the Android team could take the information and adapt to your personal usage to prolong the battery life on your phone to make sure you have the power when you need it. This sort of technology, for me, whether it's applied to Android phones or whether it's applied in data centers, which we've also worked on to reduce the power I need to keep them cool, I think as we try to usher in an era of more sustainability, they'll be really important to help optimize our infrastructure. So having shared a few examples, I'd like to just quickly return to the question I asked at the beginning, which is how do we make sure we're bringing in a safe, ethical, and inclusive AI-enabled future? Because the great promise of AI, for me, also requires great care, because we're planning for success. We're planning for an AI-enabled future, which means we need to think about now how that's going to work. We need the smartest minds in the world thinking now about how that's going to work. It's really too big and too important to move fast and break things, which is why DeepMind, pioneering responsibly, is really at the heart of what we do. For example, we make sure we have systematic review of our work. We developed a text-to-speech algorithm we called WaveNet. We recognize WaveNet could, for example, be used to help people with speech impairments communicate better. And we preemptively recognized that it could be used for deceptive purposes. So we debated that at length in internal multidisciplinary leadership groups, dedicated working groups, and other groups. And in the end, we concluded that the benefits outweighed the potential for misuse. Another example is AlphaFold, the protein folding algorithm I mentioned a moment ago. When we were developing AlphaFold, we invited over 30 experts from a whole range of different disciplines, from biosecurity, biology, academia, and many others, to really scrutinize the work we were doing, to make sure we were maximizing the benefits and understanding and mitigating the risks. And as we've rolled out AlphaFold, actually, we've worked with some amazing organizations, not-for-profits and others, to really understand the downstream impact on a step-by-step basis. So that's review. One other area I think about, and actually I would encourage you to think about too, is how do we make sure the people developing and applying AI represent broader society? One way you can do this is by investing in education and community efforts. At DeepMind, we've invested $50 million and counting in scholarships and sponsorships with incredible organizations like Women in Machine Learning and the African Deep Learning Endowment. That's the biggest machine learning community in Africa. So in summary, I think it takes a really strong, focused, and dedicated community to make sure we're building a safe, ethical, and inclusive AI-enabled future. Like the new James Webb Telescope, I believe AI will allow us to gaze farther into the future than ever before. And as we gaze into that future, we have to ask ourselves, how do we maximize the benefit of AI for society? Because we've already seen huge breakthroughs in fundamental AI research, which are having massive impacts in really important areas like health and sustainability. And I know, I'm confident, there are even bigger breakthroughs on the way, and their impact's going to be enormous. which is why, as we meet here today, I have great hope for our future. Thank you.
Wonderful. Thank you so much. It was a brilliant presentation. We've learned a lot. Thank you for your time.